Hello there, and welcome. I am so glad you found your way here tonight. Perhaps you are settling into bed after a long day, or maybe you are curled up in a quiet corner somewhere looking for a gentle companion to help you drift towards sleep. Wherever you are, whatever brought you here, you are welcome. Tonight we are going on a journey together. Not a hurried one, not one that demands anything from you, but a slow, quiet drift toward one of the most profound questions we can ask about our universe. What happens at the edge of the observable universe? Before we begin, I would love to know, just for a moment, where in the world are you listening from tonight? Are you in a place where you can see the stars, or are they hidden behind clouds or city lights? Are you warm and comfortable, or perhaps pulling a blanket a little closer? Maybe it is late at night, or maybe it is a quiet afternoon, and you simply need to rest your mind. Either way, we are here together, sharing this moment across whatever distance separates us. And that itself is a kind of wonder, isn't it? 2 points in the universe connected by curiosity and a desire for peace. If you find these gentle explorations helpful, if they give you a calm way to end your day or a soft place to rest your thoughts, I would be grateful if you tap the like button or subscribed. It helps others who might need this kind of quiet company to find their way here too. But there is no pressure. For now, you have nothing to do but breathe, settle, and let your mind wander with me into the deepest reaches of space and time. So take a slow breath. Let your shoulders drop. Feel the weight of your body supported by whatever you are resting on. Notice the air moving in and out of your lungs, steady and calm. Tonight we are going to think about edges. Not the sharp kind, not borders or walls, but something far more subtle and strange. We are going to think about the edge of everything we can possibly see. The horizon of the entire observable universe. And as we do, we will discover that this edge is not really an edge at all, but a kind of horizon made of time, made of light, made of the limits written into the very fabric of existence. The universe is vast. You have probably heard that before. Perhaps you have even tried to imagine just how vast it is. But tonight we are going to go further. We are going to drift all the way to the furthest point that light itself has been able to reach us from. We are going to stand in our imagination at the very boundary of what can be known through light. And we are going to ask gently, carefully, what lies beyond that boundary. What happens out there at the edge where our vision finally fails? But here is the first thing to understand, and it is worth letting it settle slowly into your mind. The edge of the observable universe is not a place. It is not a wall in space, not a boundary you could travel to and touch. It is a horizon created by time, by the age of the universe and the speed of light. It is the furthest distance from which light has had time to reach us since the very beginning of everything. That beginning was about 13.8 billion years ago, and light fast, as it is traveling at 300,000 kilometers every single second, has limits. It can only go so far in a given amount of time. Imagine you are standing on a beach at dawn. The horizon stretches out before you, the line where the ocean seems to meet the sky. You know, of course, that there is more ocean beyond that line. Ships sail past it. Islands exist beyond your view. But from where you stand, that is as far as you can see. The horizon isn't a wall. It is simply the limit of your vision from that particular spot. The edge of the observable universe is like that. Only instead of being limited by the curve of the Earth, we are limited by the age of the universe and the speed of light. Let that image rest in your mind for a moment. The horizon on the ocean. The gentle line where sight ends but reality continues. Feel how that not a frightening limit, but a natural one. A boundary that defines your view without erasing what lies beyond. Now here is where it gets interesting, where the universe reveals one of its most beautiful puzzles. You might think that if the universe is 13.8 billion years old, then the edge of the observable universe would be 13.8 billion light years away. That would make sense, wouldn't it? Light traveling for 13.8 billion years should cover 13.8 billion light years of distance. But the universe has a secret. Space itself has been expanding all this time. And that expansion stretches everything, including the distance light has traveled. So while the light we see from the most distant objects has been traveling for nearly the entire age of the universe, those objects are now much, much farther away than 13.8 billion light years. In fact, they are about 46 billion light years away. And that means the observable universe, the sphere of everything we can possibly see with light, stretches about 93 billion light years across. 93 billion light years. That number is so large it almost loses meaning, doesn't it? Let it sit there without trying to grasp it fully. Sometimes the mind doesn't need to hold a number completely. It just needs to feel its weight, its immensity. Think of it this way. Imagine you send a friend to walk across a field toward you, and they start walking the moment you are born. They walk at a steady pace, never stopping for your entire life. But while they are walking, the field itself is stretching slowly, steadily, pulling them back even as they move forward. By the time they reach you decades later, the starting point where they began is now much farther away than it was when they started. The field has grown. That's what the universe has been doing, expanding while light travels through it, so that by the time ancient light reaches us, its point of origin has been carried much farther away. This is one of the most humbling things about cosmology. The universe is not just large. It is large in a way that defies our everyday intuition. It is large in a way shaped by motion, by expansion, by the strange geometry of space-time itself. And the edge of what we can see is not a fixed distance. It is a moving, shifting horizon defined by how long light has been traveling and how much space has stretched in the meantime. But let's step back for a moment. Let's not get lost in the numbers just yet. Instead, let's think about what observable universe really means. Because this phrase, which sounds so technical, holds within it a kind of poetry. The observable universe is everything that has been able to send light to us. Everything whose existence we can confirm through the photons, the particles of light that have completed the long, long journey across space to reach our telescopes, our eyes, our instruments. It is the collection of all possible evidence written in light. And here is the beautiful part. The observable universe is centered on us. Not because we are special, not because we are at the center of creation, but simply because we are the observers. Every point in the universe has its own observable universe, its own sphere of vision defined by the light that can reach it. Someone in a galaxy 10 billion light years away would see their own observable universe centered on them, filled with different galaxies at different distances. Some of the galaxies they see we cannot. Some of the galaxies we see they cannot. Our spheres of vision overlap, but they are not identical. This is important, and it is worth pausing on. It means the edge of the observable universe is not the edge of the universe itself. It is only the edge of what we can see from here, from now. Beyond our horizon, the universe almost certainly continues. More galaxies, more stars, more structure stretching outward in ways we can measure and infer, but never directly observe. The universe is larger than our view of it. Perhaps infinitely larger. We simply don't know. Imagine a vast dark forest at night. You are standing in a clearing with a lantern. The light from your lantern reaches only so far, illuminating the trees within a certain radius. Beyond that circle of light, the forest continues. You can hear rustling in the distance, see shadows at the edge of your vision, but you cannot see the trees themselves beyond a certain point. That doesn't mean they aren't there. It just means they are beyond your light. The observable universe is the circle of light. The universe itself is the entire forest stretching far beyond what your lantern can reveal. So when we talk about the edge of the observable universe, we are really talking about a horizon of light and time. We are talking about the furthest point from which light has had time to reach us, stretched and reddened by the expansion of space, carrying messages from the distant past. And what we are about to explore slowly and gently is what that edge looks like, what it tells us, and what might lie beyond it in the darkness our light cannot yet touch. Take another slow breath. Let your body settle a little more deeply into rest. We have established the foundation now. We know that the observable universe has an edge, not because the universe ends there, but because light and time create a horizon. We know that this horizon is about 46 billion light years away in any direction, making a sphere 93 billion light years across with us at the center of our own view. And we know that this edge is shaped by expansion by the stretching of space itself over billions of years. From here, we are going to move closer to that edge. We are going to ask what we actually see when we look as far as our instruments can take us. We are going to discover that the edge is not empty, not dark, but filled with light from the very beginning of time. And we are going to find that the edge paradoxically shows us not the present, but the deepest past we can possibly witness. The universe at its youngest, most primordial state. But we will take our time getting there. There is no rush. The universe has been expanding for nearly 14 billion years. It can wait a little longer while we rest, breathe, and let these ideas settle like soft snow on a quiet night. The edge is waiting for us, and it has been waiting since the beginning of everything. So let drift toward that edge now slowly with gentle curiosity. Let ask the question that might already be forming in your mind. If the edge of the observable universe is the furthest point from which light can reach us, what do we actually see when we look that far? What out there at the very limit of vision? The answer is both simple and profound. What we see when we look to the very edge is not galaxies, not stars, not planets or clusters or any structure we would recognize. What we see is a wall of light, ancient light. Light so old that it comes from a time before galaxies even existed. This light is called the cosmic microwave background, and it is in a very real sense the visible edge of our universe. It is the furthest thing we can see with light, and it shows us the universe when it was only 380,000 years old. Let that sink in for a moment. 380,000 years. That sounds like a long time in human terms. But compared to the 13.8 billion years the universe has existed, it is barely a blink. It is less than 1/40,000th of the universe's current age. Imagine compressing your entire life into a single day. 380,000 years after the Big Bang would be equivalent to the first 2 seconds after midnight. That's how young the universe was when this light began its journey toward us. But why does the cosmic microwave background exist at all? What is it really? To understand that, we need to go back to the very beginning. In the first moments after the Big Bang, the universe was unimaginably hot and dense. So hot that matter as we know it couldn't exist. Atoms couldn't form because it was too energetic. Instead, the universe was a thick soup of particles, electrons, and protons, all buzzing around in a state of plasma. And in this plasma, light couldn't travel freely. Every photon, every particle of light would collide almost immediately with an electron scattering in a new direction, only to collide again and again. The universe was opaque, like trying to see through a thick fog. But as the universe expanded, it cooled. And about 380,000 years after the Big Bang, something remarkable happened. The temperature dropped enough that electrons and protons could finally combine to form the first neutral atoms, mostly hydrogen. This moment is called recombination, and it changed everything. Because once atoms formed, light was suddenly free to travel. The fog lifted. The universe became transparent for the first time. All the light that had been trapped, scattering endlessly in the plasma, was suddenly released. It streamed outward in all directions, traveling through the expanding universe. And that light has been traveling ever since. For more than 13 billion years, it has crossed the cosmos, stretched by expansion from visible light into microwaves cooled from thousands of degrees to just a few degrees above absolute zero. And now that light reaches us, we can detect it with sensitive instruments. We can map it across the sky, and what we see is the cosmic microwave background, a faint glow coming from every direction, a perfect relic of the early universe. This is the edge we can see, not a physical edge, but a wall in time. A moment beyond which light cannot take us, because before that moment the universe was opaque. We cannot see further back with light, because there was no free light to see. The cosmic microwave background is our horizon, the oldest light in the universe, the furthest view we will ever have. And what a view it is. When scientists map the cosmic microwave background, they see something almost perfectly uniform, almost perfectly smooth. The temperature is the same in every direction, about 2.7 Kelvin, just a couple degrees above absolute zero. This uniformity tells us something profound. It tells us the early universe was remarkably homogeneous, spread out evenly, without large clumps or voids. But not perfectly even. There are tiny fluctuations, small differences in temperature, less than 1 part in 100,000. These tiny ripples, these slight variations in density, are the seeds from which everything grew. Galaxies, clusters, superclusters, all of it began with these infinitesimal differences in the cosmic microwave background. It is almost overwhelming to think about IS in it. The faint glow of microwave radiation we detect today, invisible to our eyes, but measurable with radio telescopes, is a photograph of the infant universe. A snapshot taken when the cosmos was smooth and simple, just beginning to show the faint patterns that would over billions of years condense into stars and galaxies and planets, and eventually us. Let's pause here for a moment and just sit with that. Imagine you are looking at a photograph of yourself as a newborn, just hours old. In that photograph, everything that you would become is already there in potential, in the shape of your genes, in the environment around you, but not yet unfolded. The cosmic microwave background is like that. It is a baby picture of the universe, and we are part of what that baby became. Take a slow breath. Notice how your body feels right now, the temperature of the air around you, the subtle sounds in your environment, or the silence if you are somewhere quiet. You exist 13.8 billion years downstream from that moment of recombination. Every atom in your body, every thought in your mind, every star you have ever seen, all of it emerged from the seeds planted in those tiny fluctuations we see in the cosmic microwave background. Now here is something even more striking. The cosmic microwave background comes to us from every direction. It surrounds us completely, a glowing shell at the edge of our observable universe. This makes sense, doesn't it? If the entire universe was filled with hot plasma, and then it all became transparent at roughly the same time, then no matter which direction we look, we see back to that moment. Every line of sight eventually intersects with the surface of last, scattering the moment when light was freed. It is like being inside a sphere where every point on the inner surface is glowing with ancient light. But here is the beautiful, slightly dizzying part. That glowing surface, that shell of the cosmic microwave background, is not a fixed distance away. It is defined by look-back time, by how long ago that light was emitted. And because the universe has been expanding, the actual distance to the matter that emitted that light is now about 46 billion light years away. The light itself has been traveling for over 13 billion years, but the matter that emitted it has been carried away by expansion, so it is much farther now than it was then. This means when we look at the cosmic microwave background, we are seeing the universe as it was, not as it is. We are seeing a moment frozen in time, forever receding from us, forever young. Those regions of space have long since evolved, cooled, formed galaxies and stars. But we will never see what they became. We can only see what they were, illuminated by that ancient flash of light released at recombination. There is a poignant quality to this, don't you think? The edge of the observable universe shows us not the present, but the past. The further we look, the further back in time we see. And at the very edge, we see the universe in its infancy, glowing and simple and full of potential. We cannot see what happened next in those distant regions. Their present is hidden from us, carried beyond the reach of light by the expansion of space. We are, in a sense, forever separated from the current state of the edge. Imagine watching a film of someone's life, but the film stops when they are just a baby. You see their first moments, their first breath, but you never see them grow up. You never see what they became. That's what the cosmic microwave background is like. It is the first chapter of the universe story, playing on infinite repeat while the rest of the story unfolds beyond our view. This wall of light, this cosmic microwave background, is the furthest we can see with electromagnetic radiation. It is the edge in the most literal sense, the boundary of vision. Before this moment, the universe was opaque. Beyond this distance, we cannot see. And so, in one important way, this is the edge of the observable universe, the surface of last scattering, the moment the fog cleared. But it is not the only kind of edge. There are other horizons, other boundaries defined not by opacity, but by time and expansion. And those edges tell different stories, reveal different truths about what it means to live in a universe with limits. We will come to those soon. For now, let rest with the cosmic microwave background. Let appreciate it for what it is. A message from the beginning. A postcard from the universe, childhood, sent across billions of years, arriving here, now in the faint hum of microwaves filling the space around us. You are surrounded by this light right now. It is passing through you, invisible but real, a whisper from the edge of time. And in a way that makes you part of the story. You are not separate from the cosmic microwave background. You are downstream from it. You are what happened next in one tiny corner of the universe, one small thread in the tapestry that began to weave itself 13.8 billion years ago. So when you think about the edge of the observable universe, you can think of it as this: a glowing shell of ancient light surrounding us at every point on the horizon, marking the moment when the universe became transparent, showing us the seeds of everything that followed. It is the furthest we can see, and it is beautiful, and it is enough. Let that thought settle. Let it bring a sense of peace, of connection, of being held within something vast and ancient and ongoing. The edge is not a void. It is a beginning, forever visible, forever receding, forever luminous with the memory of creation. And now gently we will begin to ask what lies beyond that wall of light. Because even though we cannot see past it, we can still wonder. We can still imagine. And we can still follow the mathematics and the reasoning to understand what might be there just beyond the horizon, in the places light has not yet had time to show us. We have been resting at the cosmic microwave background, that luminous shell of ancient light marking the edge of what we can see. But now a new question begins to form gently, like a thought emerging from a dream. If the cosmic microwave background is the furthest light we can detect, does that mean it is the edge of everything? Or is there something beyond it, something that exists but simply cannot send light to us yet? This is where we encounter another kind of edge, another horizon. It is called the particle horizon, and it represents not what we can see, but what could in principle have ever sent any signal to us at all since the beginning of time. Let that distinction settle for a moment. The cosmic microwave background is the edge of light, the edge of transparency. But the particle horizon is the edge of causal contact, the boundary of everything that has had enough time to influence us in any way since the Big Bang. In practice, for light, these two horizons are very close. The cosmic microwave background comes from just 380,000 years after the Big Bang, and the universe is 13.8 billion years old. That tiny difference means the particle horizon is only slightly beyond the cosmic microwave background. But conceptually, they are different. One is about opacity, the other is about time and distance. And understanding this difference helps us think more clearly about what the edge really means. The particle horizon is essentially the answer to this question. How far away could something be and still have had enough time to send light to us since the very beginning? It is determined by the age of the universe and the speed of light modified by the expansion of space. And the answer, as we have already touched on, is about 46 billion light years in any direction. That the radius of the observable universe, the particle horizon. But here is what makes this horizon so fascinating and a little bit heartbreaking. It is always growing. Every second that passes, light from slightly farther away has time to reach us. Every day our particle horizon expands, and technically the observable universe gets a tiny bit larger. New photons arrive from regions that were previously beyond our reach. We are constantly receiving first light from places that have never communicated with us before. In that sense, the edge of the observable universe is not a static boundary. It is a moving frontier, an expanding horizon that sweeps outward as time passes. Imagine standing in the same spot while the fog around you slowly lifts, revealing more and more of the landscape. That's what's happening with the particle horizon. More of the universe is becoming observable in principle with every passing moment. And this is where the heartbreak comes in. The expansion of the universe complicates everything. Yes, our horizon is growing. Yes, new light is arriving. But at the same time, the expansion of space is carrying distant objects away from us, and in many cases, it is carrying them away faster than new light can reach us. The expansion steals more than time gives. And this means that even though our particle horizon is technically growing, we are actually seeing fewer and fewer galaxies over time. The universe is not becoming more visible. It is becoming more empty. This is one of the cruelest truths of cosmology, and it is worth sitting with for a moment. We live in a brief, precious window of cosmic history, a time when the universe is old enough that galaxies have formed and light has had time to reach us from billions of years ago, but young enough that those galaxies are still visible, still within the reach of light. In the far future, trillions of years from now, the expansion will have carried almost everything beyond the horizon. Future observers, if they exist, will see a dark, nearly empty sky with only their local group of galaxies visible. They will have no cosmic microwave background to study, no distant galaxies to observe, no evidence of the Big Bang or the expanding universe. They will live in a cosmos that appears static, isolated, and eternal. We, on the other hand, live in an age of abundance. We can see the cosmic microwave background. We can observe galaxies billions of light years away. We can measure the expansion of the universe and trace its history back to the beginning. We are cosmically lucky, living at a time when the universe still reveals itself. This thought can bring both sadness and gratitude, can it? Sadness because we know this view is temporary, that the universe is slowly erasing its own history from view. But gratitude because we are here now, able to witness it, able to look out and see the edge even as it recedes from us. So the particle horizon, this edge defined by time and light, is a moving boundary. It expands as the universe ages, but not fast enough to keep up with expansion. It is a horizon in the truest sense, always ahead of us, always receding, always defining the limit of what we can know through light. Now let's shift our attention slightly. Let's ask a different question, one that brings us back from abstraction to something more concrete. What actually at the edge right now? Not the cosmic microwave background which shows us the past, but the actual matter, the actual galaxies that are currently at the particle horizon 46 billion light years away. This is a strange question because we can never see those galaxies as they are now. We can only see them as they were billions of years ago when their light began its journey toward us. But we can reason about what they might be like today. We can use our understanding of how the universe evolves, how galaxies form and age, to imagine what those distant regions might look like in the present moment, even though we will never observe it. Let's start with what we can see. When we look out toward the edge, toward the most distant galaxies our telescopes can detect, we are seeing galaxies as they were more than 13 billion years ago. We are seeing the universe when it was very young, less than 1 billion years old in many cases. And those early galaxies look very different from the galaxies we see nearby. They are smaller, for one thing. Galaxies grow over time, through mergers, through accretion of gas, through the gradual accumulation of mass. Early galaxies are often just fragments, building blocks that will eventually combine into the large spirals and ellipticals we see in the more recent universe. They are also hotter, bluer, filled with young massive stars burning bright and fast. Star formation rates were higher in the early universe. Gas was more abundant, less enriched with heavy elements. Stars formed in intense bursts, lighting up their host galaxies with fierce blue-white light. These distant early galaxies are also incredibly faint, not because they are dim intrinsically, but because their light has been traveling for so long, and because the expansion of space has stretched that light, redshifting it from visible wavelengths into the infrared. To see them at all requires the most sensitive instruments we have. The James Webb Space Telescope, for instance, is specifically designed to detect these faint redshifted galaxies near the edge of the observable universe. And what it is finding is astonishing. Galaxies that formed just a few 100 million years after the Big Bang, galaxies that challenge our models of how structure forms, galaxies that show us the universe in a state we have never directly observed before. But here's the thing. Those galaxies, the ones we are seeing in the deep images from James Webb and Hubble, those ancient faint blue smudges of light, they are not young anymore. Not in the present. We are seeing them as they were over 13 billion years ago. Today, in their own local time, those galaxies have aged. They have merged with other galaxies, formed trillions of stars, settled into mature structures. They might be massive ellipticals now, or grand spirals, or perhaps they have merged so many times that they have become something else entirely. A giant galaxy at the center of a cluster surrounded by smaller satellites. We will never know. We can never see what they became because their present is beyond our reach. The light showing us their current state hasn't had time to get here yet, and because of the accelerating expansion, it never will. The distance between us and them is growing too fast. We are forever separated from the present state of the edge. This is one of the most poignant aspects of observational cosmology. The further we look, the further back in time we see. And at the very edge, we see only the distant past, frozen forever in the moment when that light began its journey. The edge is a museum, a gallery of cosmic youth, showing us what was, but never what is. Imagine it this way. Imagine you have a friend who lives very far away, so far that letters between you take years to arrive. You send a letter, and by the time they receive it and send a reply, years have passed. You are reading about their life from years ago, always out of date, always delayed. Now imagine that the distance between you is growing, so that each letter takes longer than the last to arrive. Eventually, the delay becomes so great that you are reading about their childhood even as they have grown old. You know they are out there, you know they are living their life, but you can only ever see them as they were, never as they are. That's what it is like to observe the edge of the observable universe. We know those galaxies are out there. We know they have evolved, changed, grown. But we can only see their baby pictures, forever young, forever distant, forever receding into the past. And yet there is a beauty in this too, because those baby pictures tell us something profound. They tell us how galaxies form. They tell us what the early universe was like. They tell us the story of how we got here, how structure emerged from smoothness, how complexity arose from simplicity. The edge, in showing us the past, teaches us about our own origins. So what at the edge right now, in the present moment, we can never observe? The best answer we can give is this. More galaxies evolved and aged, probably not too different from the galaxies we see nearby. The same physics applies everywhere, the same rules of gravity and star formation and galactic evolution. The universe is uniform on large scales. The cosmic microwave background shows us that. So we have every reason to believe that the regions now at the particle horizon have evolved in similar ways to the regions we can observe more clearly. There might be galaxies like the Milky Way out there, spirals with billions of stars, perhaps with planets, perhaps even with life. There might be massive ellipticals, the results of many mergers filled with old red stars. There might be clusters and superclusters, voids and filaments, the same large-scale structure we see in the observable universe, just shifted in time, just beyond our view. But we will never know for certain. The edge in its current state is hidden from us by the finite speed of light and the expansion of space. It exists, we are confident of that, but it exists in a present we cannot access. All we can see is its past glowing faintly at the horizon, a message sent long ago from a universe just beginning to wake. Take a moment to breathe with that, to sit with the strange, bittersweet knowledge that the edge is both visible and invisible. Visible in the past through the light that reaches us. Invisible in the present, hidden by distance and time. It is a reminder of the limits of knowledge, the boundaries written into the structure of the cosmos. But it is also a reminder of how much we can know, how far we can see, how deep into time we can look, even from our small, quiet corner of the universe. The edge shows us the beginning, and in doing so it shows us where we came from. That not nothing, that everything. Before we move on to think about what lies beyond the edge, let's pause here and sink a little deeper into the nature of horizons themselves. Because there is something profound about the way the universe creates boundaries, something that reveals not just the physics of space and time, but something almost philosophical about the nature of knowledge and existence. Think about the word horizon for a moment. On Earth, a horizon is the line where the Earth meets the sky, the boundary of your view. But you know instinctively that the horizon is not a real line. It is a product of your position, of your perspective. Move to a different spot, and the horizon moves with you. Climb a mountain, and the horizon expands. The horizon is not a feature of the landscape. It is a feature of your relationship to the landscape, of where you stand and how far you can see from there. The cosmic horizons we have been discussing work the same way. The particle horizon, the edge of the observable universe, is not a physical boundary in space. It is a boundary of light and time created by your position in the cosmos and by the finite age of the universe. Someone in a galaxy 10 billion light years away has their own particle horizon centered on them, different from ours. The horizon is personal in a sense. It is defined by the observer. This means something subtle and beautiful. It means the universe has no center, no edge, no preferred location. Every point in space can claim to be at the center of its own observable universe. You are at the center of yours. A distant galaxy is at the center of theirs. Neither of you is more central than the other. The cosmos is democratic in this way. It gives every observer their own sphere of vision, their own horizon, their own edge. But it also means that horizons are about separation. They divide the universe into what you can see and what you cannot, what can influence you, and what cannot, what is within reach, and what is forever beyond. Horizons create islands of causality, bubbles of connection surrounded by regions that are unreachable, unknowable, separate. And yet those regions beyond the horizon are not gone. They are not erased. They exist just as real as what you can see, just as governed by the same laws. The horizon doesn't change them. It only limits your access to them. It is a boundary of information, not existence. Let that settle for a moment. The universe beyond your horizon is just as real as the universe within it. But you are separated from it by light and time, by the structure of space-time itself. This separation is not arbitrary. It is woven into the fabric of reality. And it tells us something important. The universe is not entirely knowable from any one position. Knowledge is local. Perspective is limited. And that's okay. In fact, it is more than okay. It is necessary. If there were no horizons, if light could travel instantaneously across infinite distance, if the universe had no structure of time and causality, then everything would influence everything else all at once. There would be no separation, no distinct events, no flow of time. The universe would collapse into a single, undifferentiated now. Horizons, in creating limits, also create structure. They make time meaningful. They make events distinct. They make stories possible. Think about your own life for a moment. You have horizons there too. You can know the future. You can change the past. You can only influence a certain sphere around you, the people you can reach, the places you can visit, the moments you can affect. Beyond that sphere, the world continues, but outside your control, outside your knowledge. And that's what makes your life a story. If you could see everything, know everything, control everything, there would be no journey, no discovery, no growth. The horizons of your life, the limits of your knowledge and power, are what make your existence meaningful. The universe works the same way. The cosmic horizons, the edges of observation and influence, create the structure within which galaxies evolve, stars form, and consciousness emerges. Without horizons, without limits, there would be no narrative, no history, no unfolding of events. The universe would be a static, timeless whole. But with horizons, it becomes a story, a process, a journey from the Big Bang toward whatever future awaits. And here is where it gets even more interesting. Horizons are not fixed. They change over time. The particle horizon, as we have discussed, is expanding. Every moment light from slightly farther away reaches us for the first time. The observable universe is growing slowly but steadily. In this sense, the edge is always moving, always revealing new regions of space, always expanding our view. But the event horizon, that boundary of what we will ever be able to see, is also changing. Because the expansion of the universe is accelerating, the event horizon is actually contracting in a cosmic sense. Galaxies that are within our particle horizon, now visible to us, are crossing the event horizon, slipping beyond the reach of future light. We are gaining new first views, but we are losing future views. The universe is opening and closing at the same time. This creates a kind of temporal tension, a poignant awareness that our window of visibility is finite, not just in space, but in time. We are living in a specific era, a specific chapter of cosmic history, when the universe is old enough to be interesting, but young enough to be observable. Before us, the universe was too young, too hot, too opaque to see clearly. After us, it will be too old, too expanded, too empty to reveal its full story. We are in the middle, and the horizons remind us of that. They tell us when we are not just where we are. They orient us in time as much as in space. Let's think about time itself for a moment, because horizons are fundamentally about time. The particle horizon is defined by the past, by how much time has elapsed since the Big Bang. The event horizon is defined by the future, by what will ever be able to reach us, even if we wait forever. And the cosmic microwave background marks a specific moment in time, 380,000 years after the beginning, frozen at the edge of our view. Time in cosmology is not just a sequence of moments. It is a dimension woven together with space into the fabric of space-time. And the expansion of the universe is in a very real sense the flow of time made visible. When we see distant galaxies receding, redshifted by expansion, we are watching time unfold across space. The further away a galaxy is, the further back in time we see it, because light takes time to travel, and the universe has been expanding all the while. This means the edge of the observable universe is also the edge of time in a sense. When we look at the cosmic microwave background, we are looking back to nearly the beginning of time itself. We can see further back because time as we understand it doesn't extend further back. Before the Big Bang, before the moment when space and time and matter all came into existence, there was no before. Time itself began. This is one of the hardest concepts to grasp, and it is okay if it feels slippery if it doesn't quite settle into place. The idea that time has a beginning, that there was no time before time, challenges our everyday intuition. We are used to thinking of time as an infinite river flowing from the infinite past toward the infinite future. But cosmology tells us otherwise. Time is finite in one direction. It started, and the edge of the observable universe, the cosmic microwave background, is as close as we can get to that starting point using light. But notice what this means. The edge is not just far away. It is long ago. The edge is the past made visible by the journey of light. When you look at the night sky, you are not seeing the present. You are seeing history layered in concentric shells around you. The moon as it was a second ago. The sun as it was 8 minutes ago. Nearby stars as they were years ago. Distant galaxies as they were billions of years ago. And at the very edge, the cosmic microwave background, as it was over 13 billion years ago. You are surrounded by the past. The present, your present, is a single point in time and space. Everything else is memory frozen in light traveling across the universe to reach you. The edge is the deepest memory. We can access the oldest light, the earliest moment. And in that light, we see the universe as it was, not as it is. This temporal structure of the observable universe is one of the most beautiful aspects of cosmology. It means we are not just looking out into space. We are looking back into time. We are time travelers in a sense, using light as our vehicle, journeying backward toward the beginning with every observation, every measurement, every photograph of a distant galaxy. And the edge, that furthest horizon, is the limit of our time travel. We can go back further than the cosmic microwave background can see, earlier than 380,000 years after the Big Bang, because the universe before that was opaque. The edge is a wall in time, not space. A moment beyond which light cannot take us, not because there's nothing there, but because there was no free light to carry the message. So when we think about horizons, we are really thinking about the structure of time and space, about how light connects distant regions, about how the universe reveals itself through the journey of photons across billions of years. The horizons are not obstacles. They are teachers. They show us the limits of light, the flow of time, the expansion of space. They give structure to the cosmos, create boundaries that make knowledge possible, define the observable in ways that make wonder inevitable. Rest with this for a moment. Let your mind drift through the idea of horizons, these boundaries that are not walls, but perspectives, limits that are not endings, but definitions. The universe has edges, but they are edges of light and time, shaped by expansion and age, personal to every observer, moving with the passage of moments. You are at the center of your own observable universe, surrounded by horizons in every direction. And those horizons, far from confining you, connect you to the vastness beyond, remind you of your place in time, invite you to wonder about what lies past the edge, just beyond the reach of light. The horizons are there, patient and luminous, marking the boundary between the visible and the invisible, the known and the unknown, the past we can see and the present we cannot. And that boundary, that edge, is one of the most profound features of the cosmos. It tells us we are limited, and in that limitation, we find meaning. So we have arrived at a threshold. We have looked as far as light can take us. We have seen the cosmic microwave background glowing at the edge of transparency. We have thought about the particle horizon, that moving boundary of everything that has had time to send us a signal. And we have imagined the galaxies at the edge as they are now evolved and aged, hidden from us in an unreachable present. But now comes the question: what lies beyond the edge? Does the universe simply stop at the particle horizon? Or does it continue stretching outward into regions we can never observe? And if it does continue, what out there? More of the same, or something different? Something unexpected? Let's settle into this question slowly, because it touches on some of the deepest mysteries in cosmology. The first thing to understand is that almost every scientist agrees the universe does not end at the observable horizon. There's no reason to think it would. The universe doesn't know we are here. It doesn't care about our line of sight. The particle horizon is our limit, not the universe. Beyond it, space almost certainly continues. Think about it this way. Imagine you are in a vast, dark library. You have a flashlight, and it illuminates a sphere of books around you. Beyond that sphere, you know there are more shelves, more books stretching into the darkness. The edge of your light doesn't mean the library ends. It just means you can see any farther. The universe is like that library. Our observable universe is the sphere of light. Beyond it, more space, more galaxies, more structure, continuing in ways we can measure indirectly, but never observe directly. But here's where it gets interesting. We don't know if the universe is infinite or finite. Both options are possible. Both are consistent with what we observe. If the universe is infinite, then beyond our observable horizon lies an infinite expanse of space, filled with an infinite number of galaxies, an infinite amount of matter and energy, all governed by the same laws of physics we see here. If the universe is finite, then it has some total size, some total volume, but that volume is almost certainly much, much larger than the observable universe. In either case, they're more out there than we can see. The cosmic microwave background gives us a clue, though. It's remarkably uniform. The temperature is the same in every direction to an extraordinary degree of precision. This uniformity suggests the universe is homogeneous on large scales. It's the same statistically everywhere. There are no special regions, no cosmic centers, no edges where things change dramatically. This principle is called the cosmological principle, the idea that the universe looks roughly the same from any vantage point, that we are not in a special location. If the cosmological principle is correct, and all evidence suggests it is, then what lies beyond our observable horizon is probably more of the same. More galaxies, more clusters, more voids arranged in the same patterns we see here. The universe beyond the edge is not a foreign land with different rules. It's an extension of what we know, governed by the same gravity, the same expansion, the same physics. But we can never be completely certain. There's always the possibility, however remote, that on scales much larger than the observable universe things change. Maybe the density of matter varies. Maybe the expansion rate is different. Maybe there are regions where the laws of physics, for reasons we don't understand, take on different values. We can rule this out entirely because we can observe it. The beyond is by definition beyond our reach. This is where cosmology brushes up against philosophy. We are used to knowledge being confirmed by observation. But the universe beyond the observable horizon can never be observed, not by us, not by anyone in our causal bubble. And yet we can still reason about it, make inferences, construct models. We can say with high confidence that it probably exists and that it probably looks like more of what we see here. But we can never prove it. We can never point a telescope in that direction and confirm it. There's a kind of humility in this ISN there. An acceptance that some things are beyond the reach of science, not because science is limited in method, but because the universe itself imposes limits. The speed of light, the age of the cosmos, the expansion of space, these are not failings of our instruments. They are features of reality. And they mean that some questions, no matter how much we want to answer them, will remain open. But let's think about what this means in more personal terms. If the universe continues beyond the observable horizon, and if it governed by the same physics, then somewhere out there, far beyond our view, there might be galaxies very much like the Milky Way. There might be stars very much like the Sun. There might be planets very much like Earth. And on some of those planets there might be life. There might even be beings who, like us, are looking out into their own observable universe, wondering what lies beyond their own horizon, never knowing that we are out here beyond their reach, just as they are beyond ours. Every observer in the universe has their own particle horizon, their own sphere of vision. And those spheres overlap in some places and diverge in others. Some of the galaxies we see, they cannot. Some of the galaxies they see, we cannot. We are all looking out from our own centers, all limited by the same laws, all wondering about the same edges. In a way, this connects us. Even if we can never meet, never communicate, never share our observations, we are all part of the same cosmos, all asking the same questions, all confronted by the same horizons. There's a loneliness in that, but also a strange kind of companionship. The universe is full of observers, perhaps all separated by distance and time, all looking out into the dark, all seeing their own piece of the whole. All wondering if they're more. We are not alone in our curiosity. We are just alone in our particular sphere of light. Now some scientists have speculated about what lies beyond in more exotic terms. They're the idea of the multiverse, the notion that our universe might be just one of many, each with its own properties, its own laws, its own history. In some versions of this idea, these other universes lie beyond our observable horizon, forever separate, forever unreachable. In other versions, they exist in parallel and higher dimensions or as separate branches of quantum reality. These ideas are fascinating, and some are grounded in serious theoretical physics, but they are also highly speculative. We have no direct evidence for a multiverse. We have no way to test the idea, at least not yet. For our purposes tonight, for this gentle journey to the edge, we don't need to venture into multiverses. It's enough to recognize that beyond our observable universe, there is almost certainly more universe. More space, more time, more galaxies. Whether it infinite or finite, whether it exactly like our region or subtly different, we may never know. But the not knowing is part of the story. The edge is not just a boundary of vision. It's a boundary of knowledge, a place where science meets mystery and accepts the limits gracefully. Let's pause here and take a breath. Let your mind rest with the idea of the beyond, not as something frightening or empty, but as something vast and continuous. The universe doesn't end at the edge of our sight. It goes on probably forever, or at least far beyond anything we can measure. And in that continuation, there's a kind of comfort. We are not living in a bubble surrounded by nothingness. We are living in a small, visible part of something much larger, something that stretches beyond the horizon in all directions, filled with light and matter. The same physical laws that govern our own corner of space. The beyond is unknowable, but it's not separate. It's part of the same fabric, the same cosmos. We are inside it, not outside looking in. And the edge, that horizon of light and time, is not a wall dividing us from the beyond. It's just the limit of how far we can see from here, from now. Someone else, somewhere else, sees a different edge, a different horizon. And together, all those horizons, all those spheres of vision cover the universe in overlapping circles of light, each observer at the center of their own view, each one part of the whole. This is what lies beyond the edge. Not darkness, not nothingness, but more. More galaxies, more stars, more space. More of the universe continuing in ways we can infer, but never directly witness. They're just beyond the light, just beyond the horizon, real and vast and ongoing. And knowing it there, even if we can see it, changes how we think about the edge. It's not an ending. It's a continuation, hidden by distance, revealed only in the imagination and the mathematics that describe it. So rest with that. Let the beyond be a mystery, but a gentle one. A reminder that the universe is larger than our view, richer than our observations, more extensive than any map we could ever make. The edge is not the end. It's just the furthest we can see. And beyond it, the story continues, written in light we will never detect, in galaxies we will never name, in stars that shine for no one but themselves. The universe goes on, and that in its own way is deeply comforting. We have been thinking about the edge of what we can see, the particle horizon, and the edge of what lies beyond, unknowable, but probably there. But there's another edge we need to talk about, one that perhaps even more unsettling, even more profound. This is the event horizon of the universe. Not the event horizon of a black hole, but something similar in concept. A boundary beyond which events can never influence us, no matter how long we wait. A forever edge drawn by the accelerating expansion of space. Let's approach this slowly, because it requires us to think about the future, not just the past. The particle horizon we have been discussing is defined by the past. It's the boundary of everything that has had time to send light to us since the Big Bang. But the event horizon is defined by the future. It's the boundary of everything that will ever be able to send light to us, even if we wait forever. Why would such a boundary exist? The answer lies in one of the most startling discoveries of modern cosmology. The expansion of the universe is not slowing down as you might expect from the pull of gravity. It's speeding up, accelerating. Galaxies are not just moving away from us, they are moving away faster and faster over time. And this acceleration is driven by something we call dark energy, a mysterious component of the universe that acts like a kind of anti-gravity, pushing space apart. We don't know what dark energy is. We don't know why it exists or where it comes from. but we can measure its effects, and those effects are dramatic. About 70% of the energy in the universe is dark energy, and because of it, distant galaxies are accelerating away from us. The farther away they are, the faster they recede. And at some distance, they are receding faster than the speed of light. Now, this doesn't violate relativity. Nothing is moving through space faster than light. But space itself can expand at any rate, and when it expands fast enough, it carries distant objects away from us faster than their light can reach us. This creates a boundary, the event horizon, beyond which we will never receive light, no matter how long we wait. And here's the really heartbreaking part. Some of the galaxies we can see right now are already beyond the event horizon. We are seeing them because their light was emitted long ago, when they were closer, when the expansion hadn't yet carried them beyond reach. But the light they are emitting today, in their present moment, will never reach us. It's trying to travel toward us, but space is expanding faster than it can cover the distance. It's like running on a treadmill that's speeding up faster than you can run. You move forward, but you are still carried backward away from your goal. This means that over time, those galaxies will fade from view. Not because they are dying or going dark, but because their light will be stretched and redshifted to the point where we can no longer detect it. Eventually, billions of years from now, they will slip beyond our observable horizon entirely. They will still exist out there in space, shining and evolving, but we will never see them again. They will be gone from our view, forever separated from us by the accelerating expansion. And it not just distant galaxies. Over time, more and more galaxies will cross the event horizon. The observable universe, in terms of the number of galaxies we can see, is actually shrinking. Oh, the particle horizon is still growing technically, as light from farther away has time to reach us. But the acceleration means we are losing galaxies faster than we are gaining new light. The night sky is slowly emptying. Let that settle for a moment. The universe is not just expanding. It is expanding in a way that isolates us more and more over time. In the far future, trillions of years from now, observers in the Milky Way, or whatever galaxy our descendants might inhabit, will look out and see almost nothing. The local group, our gravitational neighborhood, will still be visible, bound together by gravity, immune to the expansion. But everything else, all the distant galaxies, all the clusters and superclusters, all the evidence of the Big Bang and the cosmic microwave background, all of it will have faded beyond the horizon. The universe will appear small, quiet, and static. Future astronomers will not be able to discover the expanding universe. They won't see distant galaxies receding. They won't detect the cosmic microwave background. They will live in a cosmos that seems eternal and unchanging, with no evidence of a beginning or an end. They will have no way to know what we know. The universe will have hidden its own history from view. This is one of the most profound lessons the event horizon teaches us. We live in a privileged time, not because the universe has arranged itself for our benefit, but simply because we happen to exist at an era when the cosmos is still transparent, still filled with visible galaxies, still young enough that its history is written in the sky. In a sense, we are lucky. We can see the universe for what it is: dynamic and expanding and full of light. Future observers won't have that privilege. They will be surrounded by darkness, with only a handful of nearby galaxies to study and no way to know that they are living in the remnant of something once far grander. There are melancholy to this, isn't there? The universe is beautiful now, filled with billions of galaxies, each one an island of light in the dark. But that beauty is temporary. The expansion is erasing it slowly but inevitably, carrying the galaxies away, dimming the lights, emptying the stage. It's like watching a sunset that will last for trillions of years, the sky growing darker and darker, the stars winking out one by one until only a few remain. But there's also gratitude in this knowledge. We are here now in the age of visibility. We can look out and see the cosmic web. We can detect the afterglow of the Big Bang. We can measure the expansion and trace the history of the universe back to its beginning. We have the privilege of knowledge, the gift of a transparent cosmos, and we should cherish it, because it won't last forever. The event horizon is already at work, already separating us from distant regions, already beginning the long, slow process of isolation. This event horizon is different from the particle horizon. The particle horizon is about the past, about what has had time to reach us. The event horizon is about the future, about what will ever be able to reach us. And because the expansion is accelerating, the event horizon is closer than the particle horizon. There are things we can see now that we will never see again. There are galaxies whose past is visible, but whose future is forever hidden. Imagine standing on a shore watching ships sail away. Some are close enough that you can still see them clearly. Others are farther, fading into the distance. But at some point a ship crosses the horizon and disappears, not because it stopped existing, but because the curvature of the Earth has carried it beyond your line of sight. You know it's still out there, still sailing, but you can see it anymore. The event horizon is like that, only it not the curvature of Earth, but the expansion of space that carries things beyond reach. And once they cross that line, they are gone from view forever, no matter how long you watch, no matter how powerful your telescope. The event horizon is the forever edge. It's the boundary of everything we will ever be able to observe, even in principle, even if we wait for the rest of time. It's a limit imposed not by our technology or our understanding, but by the structure of the cosmos itself. And it already at work, already separating us from regions of space we might have been able to see if we had been born earlier in a universe less expanded, less accelerated. So when we ask what happens at the edge of the observable universe, part of the answer is this: the edge is moving. The particle horizon is expanding, but the event horizon is contracting in a sense. More galaxies are slipping away than are coming into view. The universe is closing itself off from us slowly, gently, but inexorably. And we are living in the narrow window of time when we can still see it in its fullness. Take a breath. Let your body settle. This is heavy knowledge, but it also beautiful in its own way. The universe has limits. Not arbitrary limits, but limits that arise from the nature of light and space and time. And those limits shape our story. They define what we can know, what we can see, what we can wonder about. They make knowledge precious because it's finite. They make observation valuable because it's temporary. The event horizon is the edge. We can never cross the boundary of the forever unreachable. But it's also a reminder that we are here now, able to see, able to measure, able to understand. The cosmos is revealing itself to us in this moment, in this age, and we should pay attention. We should look while we can. Because the night sky is slowly dimming, the galaxies are slowly fading, and one day far in the future the view will be gone. But for now the edge is still visible. The horizon is still bright with ancient light. And we are here to witness it, to think about it, to let it fill us with awe and humility and a deep, quiet peace. The event horizon is the forever edge. But it hasn't taken everything yet. Not yet. We have traveled through concepts and theory, through horizons and expansions, through time and light. But let's bring it back now to something more immediate, more personal. Let's think about what it actually feels like to observe the edge, to point a telescope toward the most distant reaches of space and try to glimpse that boundary where vision fails. Because this isn't just an abstract exercise. Real people, astronomers and cosmologists, spend their lives studying the edge. They build instruments sensitive enough to detect the faintest whispers of light from the earliest galaxies. They analyze data pixel by pixel, searching for patterns in the cosmic microwave background. They calculate and measure and refine their understanding, pushing the boundary of the observable outward, one observation at a time. And what they see when they look toward the edge is not emptiness, not darkness, but something far more subtle and profound. They see structure. They see light. They see the fingerprints of cosmic evolution written in wavelengths and temperatures and redshifts. The edge is not a void to be feared. It a gallery to be explored, a museum of cosmic history, a window into the deepest past. Imagine for a moment that you are an astronomer working late at night in a control room somewhere. You are analyzing data from the James Webb Space Telescope, the most powerful infrared observatory ever built, designed specifically to see the earliest galaxies, the ones forming just a few 100 million years after the Big Bang. You have pointed the telescope at a patch of sky that looks empty to visible light, just a dark spot between brighter stars. But you are not looking in visible light. You are looking in the infrared, where the light from distant galaxies, stretched by billions of years of expansion, finally becomes visible. And slowly, as the data comes in, as the exposure time lengthens, as the noise is filtered out, you begin to see them. Faint red smudges scattered across the field of view. Each one is a galaxy, but not a galaxy as it exists today. A galaxy as it was over 13 billion years ago, when the universe was still in its infancy, when stars were just beginning to clump together, when the cosmic web was just starting to form. You are seeing them for the first time. No human has ever observed these particular galaxies before. Their light has been traveling for longer than the Earth has existed, longer than the Sun has been burning, longer than our galaxy has had its current shape. And it arrives now, in this moment, at this telescope, revealing itself to you. What does that feel like? There are certainly the kind of awe that makes your breath catch, that makes the room feel smaller and the universe feel impossibly vast. But there are also something quieter, a sense of connection perhaps. You are seeing light that left those galaxies when the universe was young, and that light has traveled all this way across all that time to reach you. In a sense, you are the destination. Your telescope, your detector, your eyes, they are the endpoint of a journey that began before the Earth even existed. And their humility too, because as much as you can see, you know there more you cannot. You know these galaxies are not as they appear. They have aged, evolved, changed in the billions of years since this light was emitted. They might not even exist anymore, merged with others, torn apart by collisions, transformed beyond recognition. You are seeing ghosts in a way, images of things as they were, not as they are. And the present state of those galaxies is hidden from us, forever beyond reach. But perhaps most of all, their gratitude. Gratitude that you live in an era when such observations are possible, when telescopes can reach so far, when the universe is still transparent enough to reveal its history. Gratitude that you can participate in this, that you can add a small piece to the great puzzle of cosmic understanding, that you can look at the edge and bring back knowledge. This is what it feels like to observe the edge. It not cold or clinical, though the science is rigorous and the methods precise. It deeply human. It wonder and curiosity and the quiet satisfaction of seeing something no one has seen before, of pushing knowledge a little further, of touching, however briefly, the boundary of the knowable. And it not just professional astronomers who can feel this. Anyone who looked at a deep field image, anyone who's seen those thousands of galaxies scattered across a tiny patch of sky, anyone who learned that each smudge of light is an entire galaxy, billions of stars, millions of light years across, can feel it. The edge is not distant and abstract when you see it. It immediate and visceral. It there in the image, in the data, in the photons that traveled so far to be captured by silicon and turned into knowledge. Even without a telescope, you can feel it. When you look up at the night sky, you can know that the light you are seeing is not from now, but from the past. The stars are telling you their history, showing you how they were not how they are. And beyond them, invisible but real, is the edge, the cosmic microwave background, glowing faintly in every direction, marking the boundary of the observable. You are inside the edge. You are surrounded by it. And in a strange way, that comforting. The edge defines your cosmic home. It the boundary of everything you can ever see, ever know through light, ever connect with through signals traveling at the speed of light. Inside the edge, you are part of a connected whole, a web of causality and influence stretching across billions of light years. Outside the edge, there more universe, probably, but it separates unreachable beyond your sphere of light. And that separation, that boundary, makes the inside more precious. It makes the observable universe vast, as it is feel like something coherent, something whole. You are not adrift in infinite chaos. You are inside a sphere defined and bounded, filled with galaxies and light and structure. The edge holds you in a sense. It gives shape to your cosmic neighborhood. There is meditation in this. You can close your eyes and imagine yourself at the center of that sphere, the observable universe, stretching out in all directions 46 billion light years to the edge. Every galaxy within that sphere is in principle connected to you by light. Their photons can reach you. Your photons could reach them if you had a powerful enough signal. You share the same space, the same causal structure, the same cosmic history. And at the edge, the cosmic microwave background glows softly, a shell of ancient light surrounding you, marking the moment when the universe became transparent, when light was free to travel. That shell is your horizon, your boundary, your connection to the earliest moments of cosmic time. Breathe with that image. Let it settle. You are here now inside the observable universe, surrounded by galaxies and light, and the gentle glow of the cosmic microwave background. The edge is out there, defining your view, creating the structure within which you exist. And beyond the edge, the universe continues, unknowable, but real, separate, but connected, part of the same cosmos. To observe the edge is to observe yourself in a way. To see where you are in the universe, not just in space, but in time. To understand the limits of your vision and the vastness of what you can see within those limits. To feel small, yes, but also part of something magnificent, something ordered, something that reveals itself through light and patience and the slow accumulation of knowledge. The astronomers who study the edge, who spend their careers analyzing the cosmic microwave background or hunting for the most distant galaxies, are not just collecting data. They are exploring the boundary of existence, the edge of the knowable, the horizon where light and time create a wall we cannot pass. And in doing so, they are telling our story, the story of where we came from, how we got here, what the universe was like in its infancy. That story is written at the edge. And every observation, every measurement, every new image from a space telescope adds another sentence, another paragraph, another chapter. The edge is not silent. It's speaking to us in the language of light, in the grammar of redshifts and temperatures and fluctuations. And we are learning to listen. So when you think about the edge of the observable universe, think about it not as an empty boundary, but as a living frontier. A place where knowledge meets mystery, where light meets darkness, where the visible universe gives way to the invisible but real. It a place of discovery and wonder, of humility and awe, of connection and separation. And you don't have to be an astronomer to appreciate it. You just have to look up, know that the edge is out there, and let yourself feel what it means to be inside the sphere of light, surrounded by the history of the cosmos, connected to the beginning through the simple fact of observation. The edge is there. It's always there. And it waiting to teach us, to humble us, to remind us of our place in the vast and luminous universe we call home. We have journeyed to the edge now in all its forms. We have seen the cosmic microwave background, that glowing shell of ancient light, marking the moment the universe became transparent. We have thought about the particle horizon, the expanding boundary of everything that has had time to send us a signal. We have contemplated what lies beyond, the unknowable continuation of space and matter stretching beyond our view. And we have faced the event horizon, that heartbreaking boundary of everything we will ever be able to see, even if we wait forever. But before we begin to drift back, before we let our thoughts settle into rest, let pause and ask one more question. What does the edge tell us? What do we learn from these horizons, these limits, these boundaries of knowledge? The first thing the edge tells us is the age of the universe. If the universe were infinite in age, there would be no edge. Light from every point in space would have had infinite time to reach us, and the night sky would be blazing with light, from every direction, every star, every galaxy overlapping in a brilliant, overwhelming glow. But the night sky is dark, and that darkness, that simple fact that we can look up and see gaps between the stars, tells us the universe has a finite age. Light has not had time to reach us from everywhere. There are regions whose light is still traveling, regions we have not yet seen. This is called Olber's paradox, and its resolution, the darkness of the night sky, is one of the most profound pieces of evidence we have that the universe began. The edge exists because time began. The cosmic microwave background marks a moment 380,000 years after that beginning. The particle horizon marks the furthest point from which light has had time to travel since then. The edge is a signature of finitude of a cosmos that started and has been expanding ever since. The second thing the edge tells us is that the universe is expanding. If space were static, unchanging, then distances would be fixed. Galaxies would move, but only through space, not with space. But when we observe distant galaxies, we see their light stretched, redshifted, shifted toward longer wavelengths in a way that increases with distance. The farther away a galaxy is, the more its light is stretched. And the best explanation for this is that space itself is expanding, carrying galaxies with it, stretching the light as it travels. The edge makes this visible. The cosmic microwave background, which was emitted as visible and ultraviolet light, now reaches us as microwaves stretched by more than a factor of 1,000 by the expansion of space over 13 billion years. Distant galaxies show extreme redshifts, their light pulled toward the infrared by the growth of space between us and them. The edge is not just far away, it's receding. And that recession, that stretching of light, is one of the pillars of our understanding of cosmology. The third thing the edge tells us is our place in the story. We are not at the beginning. The cosmic microwave background shows us that. We are living billions of years after the universe became transparent, billions of years after the first stars formed, billions of years into a process of evolution and structure formation that's still ongoing. But we are also not at the end. The event horizon tells us that. The universe is still young enough that we can see its history, still transparent enough that distant galaxies are visible. We are living in a middle chapter, a time when the cosmos is old enough to be interesting, but young enough to be observable. This is a privileged position, cosmologically speaking, not because we are special or chosen, but simply because of timing. We exist at an era when the universe reveals itself. Future observers, if they exist, won't have that. They will live in a darker, emptier cosmos with no evidence of expansion, no cosmic microwave background, no distant galaxies to study. They will have to take much more on faith or miss the truth entirely. We, on the other hand, can look out and see the evidence directly. The edge is visible to us, and that visibility is a gift of our particular moment in cosmic time. But the edge also teaches us about limits. Not every question can be answered. Not every mystery can be solved. The universe beyond the particle horizon exists, but we can never observe it. The present state of galaxies at the edge is real, but we can never see it. The future evolution of the cosmos will unfold, but we won't be here to witness it. There are boundaries to knowledge, not because of our limitations as scientists or thinkers, but because of the structure of reality itself. And there's something freeing in that ISN there. We are used to thinking that every question should have an answer, that every problem should be solvable if only we work hard enough, think clearly enough, build better instruments. But cosmology teaches us that some things are simply beyond reach. The edge is real. The horizon is absolute. And accepting that doesn't diminish science. It deepens it. It reminds us that science works within boundaries, that knowledge is precious precisely because it limited, that wonder can coexist with mystery. The edge tells us that the universe is larger than our view of it, older than our instruments, can measure, more complex than any model can fully capture. But it also tells us that we can know something. We can see the cosmic microwave background. We can measure the expansion. We can map the large-scale structure. We can trace the history of the universe back to fractions of a second after the Big Bang. The edge limits us, but it doesn't erase us. We are small, yes. Our view is finite, yes. But within those limits, we have learned astonishing things. Think about it. From a single planet orbiting an ordinary star in a quiet corner of a typical galaxy, we have looked out and measured the size of the observable universe. We have detected light from 13 billion years ago. We have reconstructed the history of cosmic evolution. We have discovered dark matter and dark energy. We have traced the formation of galaxies, the birth of stars, the synthesis of elements. All of this from inside the edge, looking out, piecing together the story from the clues written in light. The edge doesn't make us insignificant. It makes us remarkable, because despite our smallness, despite our brief lives, and our limited view, we have understood so much. We have pushed our knowledge to the very boundary of what possible. We have looked as far as light can take us and seen the universe in its infancy. That not a failure, that a triumph. And the edge also tells us something philosophical, something that goes beyond science into the realm of meaning and perspective. It tells us that we are part of something vast, but also that vastness has structure, and not infinite chaos. It a cosmos ordered by physical laws, shaped by history, knowable in its patterns, even if unknowable in its totality. The edge defines the cosmos, gives it shape, reminds us that even infinity, if that what lies beyond, is made of parts we can understand. The limits of knowledge are not walls that confine us. They are horizons that orient us. They tell us where we are, what we can see, what we can reach. And in doing so, they make the knowable more precious. If we could see everything, know everything, measure everything, there would be no wonder left. But because there are edges, because there are horizons, because there are questions we can answer and mysteries we can solve, the universe remains endlessly fascinating. So when we ask what the edge tells us, the answer is layered and rich. It tells us the age of the universe. It tells us about expansion. It tells us our place in time. It tells us the limits of observation. It tells us that knowledge is finite but profound. It tells us that mystery is not a failure but a feature. It tells us that we belong to something larger than ourselves, and that belonging is defined by both connection and separation, by what we can see and what we cannot. The edge is a teacher. It shows us the universe history written in light. It reveals the structure of space-time through the stretching of wavelengths. It humbles us with its distance and its age, but it also empowers us because we can stand here on this small planet and look all the way to the beginning. We can see the edge. We can measure it. We can understand what it means. And that understanding, that ability to see the horizon and know what it represents, is one of the great achievements of human thought. We are not passive observers drifting through a cosmos we don't comprehend. We are active participants, asking questions, building instruments, thinking deeply about the nature of existence. The edge challenges us, but we rise to meet it. We look into the dark and find light. We confront the limits and discover meaning within them. So rest with this. Let it settle into your mind, into your body, into the quiet space where thoughts become feelings. The edge of the observable universe is not a wall. It not an ending. It a horizon, a boundary of light, and time, a teacher of humility and wonder. It shows us where we are and how far we have come. It reminds us that we are small but not insignificant, limited but not powerless, temporary but not meaningless. The edge is out there, always encircling us in every direction, glowing with ancient light, receding with the expansion, marking the boundary of the knowable. And we are here inside it, looking out, asking questions, seeking understanding, finding peace in the vastness we can glimpse and the mystery we cannot. That what the edge tells us. That what it means. And it enough. And so we have traveled together to the furthest reaches of the cosmos. We have stood at the edge of the observable universe, looked out at the cosmic microwave background, thought about the particle horizon and the event horizon, contemplated what lies beyond, and what we will never see. We have asked big questions and found some answers, but more importantly, we have found wonder. We have found perspective. We have found a way to think about our place in the vastness without feeling lost or overwhelmed. Now it is time to come back. Not to leave these thoughts behind, but to carry them gently with us as we return to the familiar, to the present moment, to the quiet room where you are listening to your breath, to your body, to the simple fact of being here, now alive, in this particular instant of cosmic time. Look up for a moment in your mind's eye. Imagine the night sky above you, the same sky humans have looked at for hundreds of thousands of years. The stars you see, if you can see them, are local. They are part of the Milky Way, our home galaxy, scattered across a few thousand light years of space. Close in cosmic terms. Neighbors. But beyond them, invisible to your eyes, but real nonetheless, are the edges we have been talking about. The galaxies billions of light years away. The cosmic microwave background glowing faintly in every direction. The particle horizon expanding slowly as time passes. The event horizon, that forever boundary already separating us from distant reaches of space. All of it is out there right now, even though you can see it. The edge surrounds you. You are inside the observable universe, not outside it. You are part of it, held within it, connected to it by the same light and matter and space-time that connects everything else. The edge is not something distant and foreign. It's the boundary of your cosmic neighborhood, the horizon of your home. And that a comforting thought is in it. You are not alone in the universe. You are not separate from it. You belong to it, and it belongs to you. The edge defines your view, but it doesn't confine you. It gives shape to the cosmos without closing it off. It's a horizon, not a wall. And horizons invite exploration, imagination, wonder. They invite you to look out and ask what beyond, even if you can never see it. They invite you to appreciate what visible while it lasts. Because remember, we live in a rare and precious window of time. The universe is still transparent. The galaxies are still visible. The cosmic microwave background still glows in the sky, faint but detectable. We can see the edge, study it, learn from it. Future observers won't have that privilege, but we do. And that makes this moment special, this era of cosmic history when the universe reveals itself. So as you rest tonight, as your breathing slows and your thoughts begin to drift towards sleep, you can carry this with you. You are part of something vast, something ancient, something that stretches far beyond the horizon of light. You are made of the same atoms that were forged in stars, the same matter that emerged from the Big Bang, the same substance that fills the universe from edge to edge. You are not separate. You are woven into the fabric of existence. And the edge, that boundary we have been thinking about all this time, is not a threat. It's not a void. It's a reminder of scale, a marker of time, a symbol of the limits that make knowledge precious. The edge is out there, glowing softly with ancient light, receding slowly with the expansion of space, defining the boundary of the observable without erasing what lies beyond. You can rest beneath that edge. You can let it hold you, orient you, give you perspective. The universe is larger than you can see, older than you can imagine, more mysterious than you can fully comprehend. But you are part of it, and that belonging is enough. Take one more slow, deep breath. Feel the air entering your lungs, filling your body with oxygen that came from stars, that cycled through plants, that connects you to the living world around you and to the cosmos beyond. You are here. You are breathing. You are thinking about the edge of the universe, and in doing so, you are participating in the universe's attempt to know itself. The edge is waiting, patient and luminous, at the horizon of time and space. It will be there tomorrow. It will be there for billions of years to come, slowly receding, slowly fading, but still there, still marking the boundary of the visible. You don't have to solve it tonight. You don't have to understand it completely. You just have to rest with it, let it be part of your awareness, let it give you peace. The stars will rise and set. The galaxies will drift and merge. The expansion will continue, patient and inexorable. And you small and temporary and beautiful will rest here inside the observable universe, part of the story, connected to the edge by light and gravity and the quiet wonder of existence. Good night. Sleep well. And know that the edge, vast and luminous and forever receding, holds you gently in the darkness, a horizon of light surrounding you in every direction, marking the boundary of the knowable and the beginning of the mystery beyond. The universe continues. The edge glows softly, and you can rest now. Good night.